Hello guys, Anos here. Today I will continue with the project of the last time, and in this case I will do the artificial intelligence of the sprite. But first I will add a thing that I forgot the last time, that is add a flag on the change animation from start and animation routine that avoid to execute the animation routine if I execute the change animation from start routine. For that, I will set the value 1 to the scratch RAM 8A, and then on the animation routine, if 8A is the value 0, it will be executed. If not, then it will be skipped. Also, I must add this flag to 0 on state match on before call the animation routine and all the logic of the sprite. For that I will use the state machine. Now I will explain what is a state machine. I won't be very specific with this because a state machine could be very complex to explain. There are a lot of theory about this, but basically first I will do a state machine with one state per animation. Then for that, first I will need the states of the names of each animation. Give me a second. Basically, a state machine is like a big if else. Well, in the case of that you came from an higher level language, a state machine is like a giant switch case. Well, in this case, to do a switch case, I will use two tables and one routine per state. Then the state 0 will be idle, the state 1 will be spin start, etc., etc., etc. Well, let me do the tables. So basically, if the state is 0, then the routine that will be executed is idle. If the routine is 1, the routine that will be executed is spin start and consecutive. Let me finish this table. Well, I have a table for state loop, another for state start. The state loop will happen always, and the state start will happen just when the state was recently changed. Then I will do one state per. I will do one state per animation. For that, I do this. I add the labels. I also need to restore the sprite index with this. Okay. Then, what will do the state machine? First, I will check if the animation is equals to the state. For that, I will do this compare animation index equals to state. If it is equals, then I jump to the state loop. Otherwise, I will execute the state start. Let me copy this a line. Well, this line that I will add is to synchronize the dynamic routine of the dynamic sprite of 30 FPS. If this is if the end flag is not 0, then I can change the frame or the animation. I will use this, then I will change the animation to be the same than the state. Then I load the state, and I change the animation from the start. For that I can use this. I forgot the. Okay, change animation from start, and that will change the animation. Now I will load the state on X register to index the table. I will multiply per 2, and then I will do a jump uh, like this. That will execute the routine that is indexed by the table. Okay, for now this should do nothing because I didn't define what does each state, but we will check. I will call the state machine here, and I will check if it is not crashing. Well, I will write some explanations here uh, to have all more clear. Basically, first I set the value 0 to 8a. Then, if 8a is 0, the animation routine will be executed. But if the change animation from start is called, then the value of 8a will be 1. Then the animation routine won't be executed and it will be skipped. Uh, that is why I use this line. Let me write it. Now, if the I will check if the animation index is equal to the state, and for that I do this. If the animation index is equal to state, I jump to the state loop. I will write it in this way. This is to synchronize the dynamic routine of dynamic sprite of 30 FPS. If the end flag is 0, if the end flag is not 0 after this, then I jump to the state start. Oh wait, that is not the end flag, it's the 0 flag, zeta flag. 0 flag. Well, now I will load the state and store it on the state index and then change the animation from the start. And then I will load the routine that I want to execute and jump to that routine. On the stage loop, I do the same, but with the loop of the routine. Yeah, basically this table is for loop and the other is for start. Well, now I should execute this. Okay, I forgot to add the state define. I will add it on the start of the file, on the defines section. I will use a mix table. I usually use the mix table 8. You can use any mix table. I will copy this here to start with the state 0. And now I will insert the sprite and look if it is not crashing. Okay, all is working fine. The next step is we'll do the idle state. Well, now I will code the idle state. For that, I will do a little summary first. Basically, if the player is in range, when I mean in range, I am saying that the distance between the sprite and the player is less than a certain amount of pixels. In this case, I will use 6 tiles. I think is a good number. Well, basically, in math terms, is the absolute value of x position of a sprite subtract player x position less than the range. That is a number in pixels. Also, this will have a timer if the sprite, uh, if the time of the if the wait time finish, then the sprite uh, will start to do another thing. In this case, in both cases, will pass to the state spin start. Okay, then to do the timer, I will need a define. For that, I will use one of the mist table that is a deck timer. Deck timer decreasing one every frame. I will call it attack timer because I can use it in other states. Wait, give me a second to open a file, open the file with that define. Then it will be autocomplete. Okay, attack timer number one I will use for the attack timer. And I think I will use a constant. Yeah, I will use a constant for the number of frames that will wait. I will call it attack time, and it will be 40, maybe 80. Yeah, 80 is fine. Okay. I will load the constant and load it on the attack timer. That in the sprite init, and also I will copy this on the state start of the evil state here. Okay. Now the first that I will do is the player is in range routine. I think I will use a routine first, or maybe I will use the timer first. To apply the timer, we'll check if the attack timer is 0. If it is not 0, then skip. If it is 0, then go to the spin start state like this. I will load number 1, state number 1. Well, execute this. That will change to the spin start. And now I will do a function to calculate the range if the player is in range. Then for this I will use 3 scratch frames. 0, 0 will be the position of the sprite. Well, let me 0, 0 equals to the position of the sprite in 16 bits. The scratch 2 will be the offset or the range. No, we will use no. Scratch 2 will be the offset of the sprite. This offset will be added to the position of the sprite, and the scratch 4 will be the range in pixels. Then I will change to we change to 16 bits mode first, I think. Yeah, 16 bits first. Now I will load the position of the sprite. I will add the offset. I will subtract the player position. If this value is negative, I will transform it into positive. BPL is to know if the value is positive. And I will use this to change it to positive. Then I will compare with the range. And done. That will return this carry clear if the player is in range, and carry set if it is not in range. Here I will write some comments. First load the sprite X position, then add the X offset, subtract the player X position, subtract the player position. If the value is negative, then change it to positive to get the absolute value and compare with the range. Then, as I said, this routine will return carry clear if the player is in range, and carry set in other ways. Let me load the values on the scratch RAMs. Here I am loading the values of the parameters for the function. Okay. In this case, I will use 6 dice, that is 60. And as I said, this return carries clear if the player is on the range, and carry set in other ways. Otherwise, carry set. Okay, then to get to know if the carry set, I will use BCS to skip this, and this will do this. Yeah, exactly. Now I will test it. Let me open the Pixie, insert the sprite, and check it on the ROM. First, I will check the timer. Nice. And now I will check if player is in range. Nice. Okay, all is working for now. Now the spin start routine will be very easy. Basically, I will check if the animation ends, and if the animation ends, I will change to the spin getting speed uh, state. To know if the animation ends, I can use the animation frame index and compare it with if it has the value of the last frame of the animation. For example, well, I will delete this. To get the value, I will go to the animation table. As you can see, the spin star animation has 3 frames. Then I must use 3 less 1, that is 2. Then I should use the value 2. Then if the animation frame index is 2 and the animation timer is 0, I will change to spin getting speed 2. And to do that, I will change to state 2. Let me check if it is working. It should. And now you can see that that it is working. Now the spin getting the state 2, that is spin getting speed. Well, first I will change the speed of the animation. I will use the value 0. You can use any event number. 0 is the faster animation. This will be 30 frames per second animation. Let me check it. Okay, now it is better. Now I will use the same timer to know how much time the sprite should wait to change to a spin state. For this, I will use this value, and I will copy on the state start like this. Then this will be very similar to the last state, but now I also must check the attack timer. It can change to the spin state if the attack timer is not 0. Mm, well, first I will check if the animation ends. I will do the same. In this case, this animation has 8 frames, then I should use the value 7, that is 8 less 1. And I must do the same. Well, I also will use the attack timer. And the animation timer. In this case, I will change to the state 3. A little summary to know what does the sprite. And after this, I will do the more complex state, that is a spin, that basically moves the sprite. Okay, it is working, but I think that the time is too few. Let me change the value, maybe 40 or 20. 40 better. Now I will change this because the change between both animation is too much. I will use the value 2. Let me check it. I think it is okay, but the time of the animation spin getting speed is too low. Maybe I am doing something wrong. Well, let me do the spin state, and later I will check that. Mm, Well, this routine will be if the player is at the right, um, then it adds acceleration. The acceleration is positive. If the player is on the left, and then use negative acceleration. Um, Also, I will use maximum speed. Then, if the acceleration is negative and the speed is lower than the uh, is lower than the max speed, then it will set the speed to the maximum speed. The same for the positive speed. Um, this is a very common way to code this kind of movement. Basically, if x speed is more than the max speed and the x speed is positive, then I should load the max speed on the x speed. Um, I think I forgot the x speed must be positive. Okay, now I will code that. Also, yeah, I think I should use the timer to have limited time for do this. Spin time equals ff. Oh, oh yeah, that was the bug that I had. Now it should work the spin getting speed. And I should do the same here. Attack timer equals and now if the attack timer is not 0, I skip the if the attack timer ends, then I should go to the spin end. Also, I will do a routine to get the player side. For that, I will load the sprite position. And that I do this to load it in 16 bits. And I change to 16 bits mode. And I compare the position of the sprite with the player X position. If this return carry clear, then the player is on the right. If this return player carry set, then the sprite is on the left. Okay, then I will use BCC to jump to the right level, like this. Mm, yeah, I forgot a constant for the max speed, like this. I will use 40, that I think is a good speed. We need a left label here. Well, this this will decrease the x speed because it's negative acceleration. Um, Give me a second. Okay, I forgot that. And here on the right, if the player is on the right, then the acceleration is positive. If player is on the right, if the acceleration is negative, then I check if the sprite x speed um, is negative. If it is negative and the x speed is lower than the sprite expos than the max speed, then I must set the max speed to the x speed. Then I will compare it with the max speed, negative max speed, and if it is lower, well, in this case, higher because it is a negative number, I will set the max speed to the sprite x speed, and I will do almost the same but for positive x speed. Then if the sprite x speed is positive and the sprite x speed is more than the max speed, then it will set the max speed to the x speed. Yeah, I know that it's a bit confused, but that is how it works. This will be easier to understand when I do a little summary about this. If player is on the right, then add speed. If the speed is uh, more than the speed, then um, then set the max speed to the x speed, like this. And this is basically the same but with negative. Yeah, exactly like that. Now, if uh, I will set the global flip based on the x speed. Then if the x speed is positive, I will use global flip 0. Otherwise, I will use I forgot to set the max speed at the start. Well, give me a sec. Well, I will check the global flip. If this is 0, then it will use max speed and positive. And if it is not 0, then we'll use max speed in negative, like this. I will use these sub levels for that. And now, well, we continue setting the global flip based on the x speed. If the x speed is positive, then I will use global flip 0. And if it is negative, I will use global flip 1. I think that maybe I'm doing something wrong. Is this left level? No, negative. Exactly like this. Okay. Yeah, like that. I will check it. Give me a second to get a routine. Okay, I will use this to update the position. This is a bit different than the common update position because this works also in slopes. The default, you must do a little thing before you use it to detect slopes, but in this case it will do the slope detection. And also I will check if the site, I will check the site to set the speed to 0 when it detects a wall. Okay, now I will test it. Let me check if it is all correct. Well, it is working, but not like I want. The global flip is wrong. Also, I think that the acceleration is too few, and the start spin time is too high. Yeah, like that should be okay. Uh, let me find this. Let me check if this time is better. Yeah, that is a lot better. But the global flip is wrong. I will fix it soon. Okay, we'll go to the spin state and check why the global flip is failing. Here. Oh, I am jumping to the positive flat to the positive, and I should do this. Also, I will increase the acceleration. I think it's too too few acceleration. I will use more. Okay. Okay, the global flip is backwards. It looks like the spray is doing the moonwalking. I must change this and it should work. Also, okay, let me check now. Okay, now it is working fine. I must implement the timer, but I think this is working fine. Then for the timer, it is very easy. Basically, I will do the same that I did on the other states. I will use the attack timer, and if it is not zero, if it is zero, then I will change to the spin end animation. And the spin end animation will be very similar to the spin start animation. Just check if the animation ends, and then go to the idle animation, to the idle state. Then in this case, this let me check the tables. In this case, this animation has it has 4 frames. Then I should use 4 less 1 than is 3. We use the value 3. Also checks the animation timer and change to the idle state. As you can see, it's very similar to the spin start state. Okay, now I'll test it. Something is not working. Give me a second. Oh, I used the animation timer instead of the attack timer. Now it should work. Okay, now it is working. Very nice. Well, with this, I think that we have enough for this part. In the next part, I will fix any bug that I found. like this glitch, I suppose. Also, I will finish the interaction with the sprite to hurt it and kill it. And kill it. This should be all for this tutorial. And I hope you enjoy it. And have a nice day.